Hello guys, today I'm going to show you how to find out a volume per unit height plot in SolidWorks. So what I'm going to do is I'm interested in looking at how much volume is occupied inside this Eppendorf tube per unit height. For instance, if I fill this tube for up to like 1 millimeter from bottom till above, I would like to know what's the volume of it. And if I increase the volume by height, let's say 2 millimeter, 3 millimeters, and so forth, what will be the volume occupied? So to do that, I'm going to use this Eppendorf tube, and let's begin. So the first thing is I'm not interested in this section because they are going to conflict with the volume which I'm interested in. Or maybe not, but it's better to like remove this part. So looking at the design, just to make sure this file is downloaded from GrabCAD, and I haven't really sketched this part. But yes, what I'm going to do is use this file to find out what's the volume occupied in this cavity. So we have the Eppendorf tube, which is purely cut, and now it seems to be nice. Let's fill this cavity. To do that, let's first add a plane to this surface. And it shows that the plane is 100 millimeters above it, which is somewhere over here. We don't want it to be 100, we want it to coincide. Let's click 0 and click check. There's a plane above and the Eppendorf tube. Now we are going to intersect these two parts. So the top and the base. So plane 1 and the cut extrude 1 is selected. Now let's click intersect. Now we have two parts. One is the outer part and the other one is the inner part. So the outer is not really of interest right now, but we are more interested in what happens with the filled cavity. So I'm going to check the region 2. And if I click it, all you see is the filled cavity. So let's click OK. You have the filled cavity and it's called as intersect over here. Now the next thing is to, let's say we want to cut this above region and slowly we are going to reduce the cutout by 1 millimeter or something. To do that, let's go to sketch, add a circle, and on the top surface, let's create a circle. So the circle is actually going to fill this part or this tube up to a certain height. To do that, let's go to features and click extrude cut. Now it's occupying, for instance, 10 millimeters, but I would like it to be occupying something somewhere really close to the bottom surface. I know the height of this object. It's roughly around 38.5. So I'm going to create 38 millimeters, and let's check what happens over here. So actually 38 is probably occupying too much of space. So let's make it 37.5. And now you can see a part of it is not included in the extruded cut. And this is the volume at, let's say, whatever height minus 37.5. And now I'm going to click OK for it. You will see an cut dash extrude 4 part is created. So this was your plane, and we have actually cut this region. Now, what we are going to do is we are going to reduce the extrude cut size from, let's say, the bottom by 1 millimeter in steps, and we are going to build this part and the volume occupied. So to do that, we are first going to Files and click Properties. We're going to create a property name called as, let's say, volume, because that's our interest. You can name it anything you want. Click Text, and let's see the word value expression. So you can actually add anything you want, thickness, material, mass, density, which will be occupied by this extruded cut. But since I'm interested in volume, so right now it gives you the expected value, which is 0.69, which is fine. So this is 0. Since the dimensions are in millimeter, this is going to be 0.69 cubic millimeters. Click OK. Now, the next step is to create a design table. So what I'm going to do is create different configuration files over here, which will be reducing the extrude cutout by 1 millimeter. Now, let's click Insert and go to Table, click Design Table, and click OK. So it will start populating. And now it is asking us for the dimensions we want to change. And as I told you earlier, our part is known as D1, or it's known as cut dash extrude 4. So I'm interested in this part. And the default height which we added was like 37.5. What we're going to do is like whatever height minus 1. So we are going to add height minus 1 over here. Then again, we are going to add height minus 2. And let's create it up to, um, okay. So let's see what happens over here. Now we are interested in it 37 minus 1. And let's create for the whole. So we are going to check it like what happens until, or what's the volume filled until the height is going to be, or the extrude cut is going to be 1.5. So now we have created this. Let's just click anywhere over here, or let's save this. I'll just click the outer part, and it shows that the design table is generated for the following configurations. We click yes. So now let's look at what these configurations really mean. So this is going to be height, whatever the extrude cut height was, minus 1. So it's going to be something like this. But let's go to something like a large number. Let's say h minus 30. It's going to show us this whole volume up till the extrude cut is minus 30. Oh, sorry, the height from the bottom is going to be 30 millimeters. And so either you can build this configuration by clicking one by one, or you can just go to edit and rebuild all the configurations. So if you're going to have like 1,000 parts of a particular irregular object, then clicking this edit and rebuild all configuration is going to help you. So we are done with the editing part. Now let's go back to the design table. And if you remember from this file properties, we had the property name volume. So which applies to h minus 30, and the expected value is approximately 1295 cubic millimeters or microliters, something 1300 microliters. So let's go to design files and now edit the table. So what we would like to see over here that the volume has been populated. To do that, let's go to edit table, and now it will start updating the design. The column which we are interested in adding is the PRP, or the property volume, because that's what we created in the file properties. Now let's click OK. So there are like different properties, but the only property of my concern is going to be the volume. And I'm going to click OK. So the design table gets updated. On the left-hand side, you see the height of the extrude cut. On the right-hand side, this property volume is where the volume is occupied, or how much is the volume occupied per unit height. And that's it for now, guys. You can actually copy this into whichever favorite Excel sheet or Python program, or export it to CSV for your future reference. And that's how you do it for finding out what's the volume occupied per unit height. Thank you, guys.